Good afternoon, everyone, and welcome to the Construction Specifiers Democast on Integral Concrete Waterproofing and Concrete Durability Admixtures by Kryton International. My name is Nitya, and I'll be moderating today's presentation. Before I introduce the speaker, please note your mics are muted. It would be best if you turn on the speaker view. That said, if you have any questions for our speakers, feel free to post them in the Q&A forum. We will address as many questions as possible at the end of the presentation. If you have any connectivity or Zoom-related questions, you can use the chat feature to communicate with us, and we'll do our best to help you. Today's presentation is being recorded. It will be available on the Construction Specifier website, so you can access it whenever you need to. Now, I'd like to introduce our speakers. Bill Huta is a Territory Manager for Northwest USA, and Jeff Bowman is a Technical Director at Kryton. In today's presentation, Bill and Jeff will provide an overview of Kryton's waterproofing and durability admixtures. With that, I'll turn things over to Bill.
Thank you, everyone, for your time and interest in understanding more about our award-winning integral admixtures at Kryton International. Today, we'll review in detail our high-performance crystal internal membrane waterproofing admixture, also known as KIM, as well as our high-performance integral admixture for concrete hardening and durability, known as HardSem. Both of these products are well respected by all of our construction partners around the world because of their engineered differences and great performance and value. So who is Kryton? Kryton products are the industry leader in smart concrete. We offer integral waterproofing and durability solutions that produce technologically advanced concrete. We not only offer waterproofing solutions that perform better and increase reliability, but we also make concrete last longer, speed up installation, and lower construction costs, and we make job sites safer. Kryton is a successful family-owned company and was founded 48 years ago by Mr. Ron Ewers. Kryton was the very first company to develop an internal concrete waterproofing admixture in the industry. We are a global company and have supported thousands of projects around the world in 50 different countries. Jeff, how would you like to speak to the durability of overall concrete?
Yes, thank you, Bill. I think everyone would recognize that concrete is generally considered to be a durable material, but if you look further, you'll see that there is extensive evidence of premature deterioration and that many of our concrete structures are not meeting their predicted service life and are incurring significant maintenance costs. Now, if you examine this further, you will see that almost all of the deterioration mechanisms that affect concrete involve water in some way, either by the water penetrating into and through the concrete directly, or by carrying harmful chemical agents, for example, sulfates or chlorides, into the concrete. So in order to make your concrete durable and ensure its serviceability, it must be protected from water.
Thanks, Jeff. This picture is a picture of Vancouver, Canada, where KIM has been used in approximately 40% of all building parking structures and other waterfront construction projects. These projects are some of the most severe hydrostatic water pressure conditions around, of which our partners trusted us to provide them a protected, dry structure for many years to come. KIM has been used for decades in a wide variety of applications, from underground parking garages and tunnels to drink water reservoirs, wastewater treatment facilities, virtually anywhere concrete structures need protection from water. Depending on the application, using Kryton's waterproofing solution as a system, it can contribute up to 26 lead points towards your project. KIM is a crystalline admixture that, when added to concrete, it turns the concrete into a waterproofing membrane that eliminates the need for traditional surface-applied membranes. It is the original crystalline admixture and features the best permeability reduction and self-sealing capability available in this category. Kim is the key component to our overall waterproofing system. Membranes have been used for quite some time, and because traditional waterproofing membranes are usually installed after the concrete is placed, extra space is generally required. This can significantly reduce the building footprint and limit its design. This application adds more trades to the project, is susceptible to weather, is only one line of defense for water intrusions, is susceptible to damage during installation and backfill. It's impossible to repair while significantly impacting the general contractor from getting out of the hole, as they say, which is a critical milestone in the construction schedules. For example, taking 1 meter of space away from your property line can result in a significant loss in your building footprint. This loss is amplified as your structure gets higher, which can result in a significant loss of revenue. Jeff, would you like to address Chapter 15, ACI 212?
Yes, if you're looking at the industry, you'll find that there are a variety of admixtures available to protect concrete from water. And the American Concrete Institute has done a considerable amount of due diligence to review this category, assess the products available, and describe their capabilities. ACI Report 212 on chemical admixtures describes two broad categories: PRANs, which are permeability reducing admixtures for non-hydrostatic conditions, and PRAs, which are permeability reducing admixtures for hydrostatic conditions. A PRAN would be used for damp proofing. These would be applications where you have some water or dampness, but no hydrostatic pressure, more of a light duty application. Whereas PRAs would be used where you need true waterproofing. This would be because you have a constant source of water or direct hydrostatic pressure. And crystalline admixtures are able to provide a highly reactive and long-term mode of protection in these applications. Bill, if you could advance, please. Chapter 15 provides some basic guidelines on the performance of what a PRA should be able to deliver to your project. Using a water penetration test, they should be able to reduce the permeability of that concrete by a minimum of 50% and upwards of 90%, sometimes more. They also describe that to provide a complete solution, they should be able to provide a self-sealing feature of cracks to maintain that protection long-term. And what you'll find is that only crystalline admixtures such as Kim are able to provide both of those performance requirements.
Thanks, Jeff. So this is a very important slide. As mentioned earlier, Kim is engineered differently. If you look at these two crystals under a regular microscope, you'll see a noticeable difference. Despite some crystalline manufacturers claiming they grow long, needle-shaped crystals, you can see from the two images that these claims are not entirely accurate. This difference can be and should be observed under modest magnification of just around 30 times power. The difference in crystals is directly linked to a difference in performance, which is why Kim has the highest permeability rating on the market, easily demonstrated with permeability and self-test, which Jeff will address.
Yes, so what ACI describes as the appropriate test method for a permeability reducing admixture is direct water pressure test. These methods are used because they best simulate the long-term exposure to actual service conditions in a hydrostatic environment. The type of test methods you're looking for in a report will be labeled as DIN 1048, EN 12390, or the United States Army Corps of Engineers water permeability test. Bill, there's a couple animations here. If you could just click through till we see the test result. There we go. So in these methods, water pressure is applied directly to the concrete, and then either the samples can be broken open after a period of time and the water pressure or the water penetration measured directly, or the volume and rate of water penetration can be monitored and the coefficient of permeability is then calculated. As you can see here in the picture, Kim provided significant protection compared to not only the plain concrete, but concrete treated with a different crystalline admixture. Now, when you're evaluating these test reports, make sure you're looking for third-party testing where the lab not only prepared the concrete, but also did the testing. The admixture and the control concrete should be very similar except for the admixture to make sure you're getting a true and proper comparison. Bill? Yes.
So as Jeff stated earlier, one of the key details to a successful waterproofing admixture is the self-sealing capabilities. Kim is specified at about 0.07 millimeters in self-sealing capabilities. And this particular picture here represents that actually in real life applications. And you can see that on the left that had an open crack and it ultimately did seal.
Yes, Bill. The next study we'll look at here is a corrosion study performed at the University of Hawaii. Certainly we've spoken about permeability and crack sealing, but another important feature of these products is their ability to protect reinforcement from corrosion. So this study was done by the Department of Transportation, carried out at the University of Hawaii, and was a 10-year study to evaluate various corrosion inhibiting and permeability reducing admixtures in a high corrosion marine environment. Now, this was a completely independent study that Kryton had no direct involvement in. Bill, if you could advance to the results. After 10 years, what they found is you can see the control showed corrosion and cracking and high half-cell readings, even though this was a reasonably good quality control concrete with a low water cement ratio. The Kim-treated panels performed well, they had low half-cell readings and no visible signs of corrosion. They performed as well, and in some cases better, as dedicated corrosion inhibiting admixtures, and outperformed other crystalline and other waterproofing materials.
So why do we want to use Kim? It has the highest permeability and durability on the market. ACI benchmarks for PROS. Kim improves the quality of the concrete structures, reduces the overall risk associated with water intrusion. Plug-in specifications follow latest ACI 212 guidelines. Where is Kim used? It's used in below-grade structures, water containment facilities, and marine applications. We're going to transition over here to HardSem. HardSem is our second award-winning high-performance integral admixture. To better understand the solution that HardSem brings, we need to better understand the problem, which is that concrete exposed to constant abrasion and erosion has a significant effect on the service life of that concrete. It increases maintenance costs while reducing the service life of the concrete within its structures. An interesting example of abrasive wear is this processing facility in British Columbia. Skid steer loaders were used to move material around, which created a massive amount of wear in a covered storage facility. The result was that within the first year, this facility saw concrete surface paste wear away. Within 3 years of usage, the concrete had deteriorated to the reinforcement steel. And after only 5 years, this floor was not functional and taken out of service. It was out of service for months, and the cost of replacement was significant, resulting in operations being shut down, loss of revenue, equipment removed, and installation of a brand new slab floor utilizing HardSem. The estimated cost for this total loss of revenue and remediation was in excess of about $2 million. HardSem is engineered for and highly effective in the following applications: warehouses, maintenance facilities, manufacturing operations, big box retail, piers, loading docks, parking garage ramps, recycle plants, marine applications, and many port operations. The applications for HardSem are quite literally unlimited. HardSem has been used in approximately 60 million square feet of concrete throughout North America and is very well respected for its performance and durability. HardSem makes your concrete maintenance free, and essentially turns your concrete from being a liability and converts it to being an asset within your operations. The owner of the property can now reallocate those maintenance dollars to other needs within their operations. Jeff, you want to talk about some of the versatility of HardSem?
Yes, thank you, Bill. Certainly when people are looking for abrasion resistance, the most commonly thought of application would be a floor or a warehouse, but HardSem is highly versatile and allows you to use it in sloped or vertical surfaces where some of the dry shake-on products normally used horizontally would be impossible to use. HardSem has no negative effects on the concrete. There's no negative effect on slump or air content or strength, so it's very easy for the contractor to use. It's also compatible with air-entrained concrete because it does not need to be troweled into the surface the way traditional products would be, which would otherwise cause delamination using a shake-on product. So it really opens up a lot of new applications to this type of protection. Bill, if you could advance. What we see is that some projects will use liquid hardeners to provide abrasion resistance. These are normally based on a sodium silicate or some similar chemistry that reacts with the calcium hydroxide, which is a byproduct of hydrating cement. Unfortunately, independent testing has shown that these products do not reduce abrasive wear for concrete that has been properly placed, finished, and cured. Now, they do have a benefit for remediation of improperly placed slabs that have been poorly cured or improperly finished and have a weak or dusty surface. And this is why you will often see these products called dust proofers. But in reality, they are not appropriate as a primary abrasion resistant product. You'd be better off to use a more heavy duty solution. Bill, if you could advance. Now for heavy duty applications, what traditionally would be used is a dry shake product. Now this would be a mix of hard aggregates and cement that are sprinkled on top of the fresh concrete and troweled in during final finishing. You will very likely see test reports showing very good performance from these products. These products may be very easy to apply in the laboratory, but they are actually very difficult to install in the real world where the contractor must juggle weather, setting times, bleeding rates, and at the end of the day, their own fatigue. Odds are you are not going to get what you expect when using these products. And because of the heavy troweling needed, they must never be used with air-entrained concrete or you will see delamination.
Thanks, Jeff. So trying to protect your concrete against wear and abrasion is nothing new. Dry shake hardeners have been around for many years. There are problems with the specification and application though, as Jeff mentioned. Whatever amount you specify per square foot, only a fraction will actually be applied to the concrete. Much of it will not bond or it will simply blow away. It's highly weather dependent. It's more expensive due to added labor, added time, and equipment requirements. HardSem is delivered to the job site already in the concrete mix from the ready mix provider and is ready to go. Because it's integral, HardSem is mixed throughout the slab, wall, or wherever it is being used. And lastly, there is a significant health hazard, and many state health agencies are against such products and applications. Over the past 20 years, HardSem has not only been used extensively, but it has been tested extensively as well. Back in 2004, AMEC materials testing was hired to assess performance and the properties of HardSem. One of the most recognized people in the industry, Dr. Rusty Morgan, suggested that test method ASTM C627, called the Robinson floor tester, be used due to its aggressive abrasive testing. This piece of equipment puts 100 pounds of weight on 3 hardened steel wheels and spins 5,000 revolutions at a speed of approximately 14 revolutions per minute. This test method was selected as it allows for real-world finishing techniques, since the concrete tested needs to be around 3 foot by 3 foot in size. Once concrete is tested, depth of the wheel track and mass loss is measured. Jeff, can you review some of this information on this graph?
Yes, so what you're looking at here is the difference in wear depth from the Robinson machine steel wheels after 5,000 revolutions. I would like to point out that all of these panels were made from the same concrete and finished by the same professional concrete finisher to give a fair comparison. What you'll see here is the benefit of having your hardening additive through the full depth of your concrete. With the dry shakes, once that initial protective surface layer was gone and worn away, the concrete wear accelerated. You'll see that certainly by far HardSim had the lowest abrasion loss of all the products tested. And this is still not even considering that HardSim remains much easier to install, providing far fewer installation errors in the field.
This picture is of a facility where the owner wanted a side-by-side test done within their actual operations. If you look close at both surfaces, you actually see the brush marks and broom mark finishes on the HardSim treated concrete on the right, while the control shows significant amount of wear and exposed aggregate. This is only after 4 years in service. Here's an image of a 14-year-old warehouse floor where HardSim was treated against a regular untreated concrete used side by side. After 14 years of light industrial wear from forklifts and pallet jacks, there is a noticeable difference between the HardSim treated concrete, which is the shiny smooth finish on the top of this image, and the untreated concrete, which has lost a lot of surface paste on the bottom. Both of these slabs were installed at the same time. And the control concrete is wearing at a much faster rate and is requiring some attention already after 14 years. So why use HardSim? First of all, it is the highest performing abrasion resistant product on the market. It's versatile. It can be used in air-entrained and non-air-entrained concrete. It can be used in a vertical, sloped surfaces, shotcrete, and cast-in-place applications. It makes your concrete an asset, not a liability. Where do we use HardSim? Well, HardSim is used everywhere that is in an abrasive, erosive environment: warehouses, loading bays, big box, maintenance facilities, piers, marine projects, and hydraulic structures. And that's just to name a few. We really appreciate your time and interest in our great products here at Kryton International. Jeff and I hope you learned a lot about these various product applications and how KIM and HardSim can save money, reduce construction schedules, while significantly improve the structural integrity and overall performance of your buildings. At this time, we'll take your questions. Thank you.
Thank you, Bill. Now we have some time for questions. If you have any questions, please post them in the Q&A forum, and I will ask our speakers to address them. Bill, we have a couple of questions here. I'll just go through them. The first one: when a crack occurs in concrete, any idea as to how long before self-sealing takes place?
It's a good question. Jeff, would you like to address that?
Yes. There can be a variety of performance simply because really every crack is going to be unique. It really depends on the structure, the width of the crack, and the water pressure applied to that crack. In a typical parking structure, it would not be unreasonable to expect to see that crack seal or at least significantly improve over a period of several weeks. What we recommend doing is to mark out the damp area you see around that crack and monitor it over time at about the same time of day, so you can see how quickly it is sealing to know if you're on track. At the same time, if this crack is in an area that is very critical and you need that area to be dry immediately, perhaps you need to install elevator equipment or other mechanical equipment, Kryton does provide a leak repair system that can be used to repair that crack and make it dry immediately so you can return to your normal work.
Thank you, Jeff. The next question: what is a half cell reading?
Oh, sorry. A half cell reading is an electrical measurement of the reinforcement that would give an engineer an indication of the probability that corrosion is occurring. It can be divided up into low probability, kind of medium, maybe 50-50, and high probability, 90% or more. So the half-cell readings in that case showed that it was very unlikely that there was corrosion occurring at the steel.
Okay, thank you. Next question. Does HardSim provide any resistance to oils or chemicals, say on a warehouse floor?
That is a really interesting question. It has not been evaluated specifically for that purpose, to my knowledge. The testing performance where HardSim is proven is in abrasion and resistance loss, although that certainly has piqued my interest in some research and testing that I'm now interested in.
Thanks, Jeff. Do keep us updated. So, yes, Bill.
Yeah, to add to that, many of our clients, probably, 50% of our clients still choose to seal our HardSim applied applications. It's not required. We have a product known as HydroStop and HydroPel that is a product that seals the concrete if they so do choose to do so. That can add to some of the resistance to staining and
oils and chemicals.
Oils and chemicals, on the surface of HardSim.
Okay, got it. Thanks, Bill. Another HardSim related question. This is, aside from industrial applications, would HardSim be useful for polished concrete floors in places like building lobbies?
It can be used in building lobbies. HardSim is able to be polished just as other concrete. So it's a perfect application for that as well. It's not an abrasive type of application, a lobby within a building, but it certainly can be utilized there. Okay.
Now, can HardSim and KIM be used together as an admixture, or is KIM sufficient by itself for hydrostatic pressure?
That's a great question. I'm going to let Jeff take that. We have used it together, and Jeff, maybe you can think of that case study we have.
Yes, they have been used together. They both perform. For a hydrostatic application, if your primary purpose was to protect from water and leaks or chlorides and other chemicals, KIM would be your best option. If your primary goal was to protect from surface abrasion and particle abrasion over the surface, HardSim would be your natural choice. If you did have an application where both were of a concern, you certainly could use both of the products together. They have been tested and they're fully compatible.
Okay, thank you. And the next question. So this is for an existing below grade concrete for a daylight basement. The question is, could we add a 2-inch thick pour along the water to reduce, along the wall, sorry, to reduce water penetration?
I assume this is, they're asking about KIM concrete. If you have an existing concrete building, Kryton does provide a surface applied treatment called Crystal T1 that has the same waterproofing agents as KIM. And we also have, I mentioned our repair system, which we would use first in any defects. So for an existing building, we would normally use the T1, and KIM would be used in new construction.
Okay, thank
T1
you.
can be brushed on, rolled on, or sprayed on. Very versatile.
Another question, and I guess that'll be, we may just have time for this one. What type of testing has been done with HardSim on concrete for high velocity fluid flows? If so, what velocities?
Yeah, I'll have to review some of our testing records. I don't know that we have a specific report. Sounds like they're looking for like an erosion and cavitation test, but it has been tested using a variety of surface wear and the underwater test method that uses ball bearings, but not yet to the specific criteria they're asking about.
Okay. Thank you, Jeff. And sorry, go ahead. You were saying something, Jeff? Sorry, I interrupted you.
Yes, for a unique application like that, we'd certainly be happy to work with anybody in their project team to look at their conditions and see how we can perhaps provide a solution.
Thank you. Thank you, Jeff and Bill. And that's all the time we had for questions today. Thank you for Bill and Jeff for joining us and explaining Kryton International's integral concrete waterproofing and concrete durability admixtures. A recording of the democast will be available 1 week from now. We will also send a link to the recording via email to all registrants. Thanks to everyone who attended. Before you go, please take a few minutes to give us your feedback by completing our survey. It should appear in your browser after you close Zoom. Have a great afternoon and stay safe.